Hello. In today's video, we are going to continue what we talked about yesterday with a part 2 of exponential growth and decay. So I'm going to, you might want to flip back a page, and I want to remind you at the beginning here about the A value and the B value. So if you remember, first of all, this is the format of an exponential function. The consistent features are it's going to be y equals, and then you're always going to have an exponent that is the variable x. Then we are going to plug in numbers for a and b. So the a value is this starting value or the beginning value, or in some of our examples it's like how much something's worth to begin with, and then it grows or decays. The growth and decay value is the number that gets plugged in here, and that number is calculated down here. So we have a rate, and we have to determine is it increasing or decreasing, and deciding are we adding one or taking one minus that rate. Okay, so let's get to part 2. I'm going to write over here to the side. Here is our exponential function. All right, number 5. Suppose you open a savings account with $100. The account pays an annual interest rate of 5%. Assume you make no deposits or withdrawals, and then you're going to round your answer to the nearest cent. All right, letter A. Write the equation that models the amount Y that will be in your account after X years. Okay, I need the A and the B value. Suppose you open an account with $100. That's your starting point. That's how much you begin with. The account pays an annual interest rate of 5%. Okay, so here is your R value as a decimal. So remember, you can divide, that's as a percentage. We need to convert to a decimal. You can either divide by 100 because it's out of 100%, or you can move the decimal to the right 2 spots. Oops, to the left. Gosh, I keep saying things backwards. So when you convert this to a rate, you get 0.05. Now, is it going up or down? So right here, this might be something you may or may not be super familiar with, but when you earn interest, that's a good thing. So that means it goes up. Okay, so I'm going to do 1 plus that growth value instead of 1 minus. Okay, let's plug all that in. So y equals A, 100, and then in parentheses, interest is going up. So I'm going to do 1 plus 0.05 and then raise that to the x, and then go ahead and add that in parentheses. So our equation will read y equals 100 times 1.05 raised up to the x. Okay, there's my equation that models the situation. Okay, initial amount we determined was the 100. The rate of growth I eventually calculated to be 1.05. What does the variable x represent? Letter A here kind of talks about it. It's going to be how many years, number of years. Okay, let's make a prediction. How much money would be in your account after 5 years? So there is my x value. I'm just going to be able to plug 5 in. It doesn't say like after a certain date, so I don't have to worry about adjusting that. Okay, so let's plug that in. So y equals 100 times 1.05 raised up to the 5. And again, we're just going to use our calculator here. Raised up to the 5. All right, this is money. So I'm getting $127.63. Now make sure if you ever have calculator questions, you need to ask those because it's essential that you can use your calculator, and some of the functions or some of the keys we're using might be new to you. All right, so $127.63. Okay, I want you to try number 6. So will you please stop the video? Work through A and B, and then come back to the video to check your solution. All right, I've got, starting with 75 milliliters, the amount of solution decreases, so I'm going to just write 1 minus R here just to remind me. I'm going to do that in a moment. Now, I need to convert that to a decimal. divide by 100, or you're going to move the decimal point to the left 2 spots. So my rate is going to be 0.164. All right, write an equation for the amount of solution y that will be left after x hours. Okay, y equals 75, and then in the parentheses I'll have to do 1 minus 0.164 raised to the x, and then 1 minus 0.164 is going to be 0.836. So your equation is 75 times 0.0836 raised to the x. All right, now we're going to use this in part B. Approximately how much solution will be left after 3 hours? Now it does say here that x represents hours, so I'm just going to plug 3 in for x. So 75 times 0.836 raised up, no, not to the x, raised up to the 3. Now I expect it to go down, it's decreasing, so I should get a number under 75. So 75 times 0.836 raised to the 3. And let's just round to the nearest hundredth. It doesn't really tell me, so we'll just make a decision. 43.82, and then this isn't dollars. Go back to the top. This is milliliters. Okay, 43.82 milliliters. Okay, so a couple of things I want you to pay attention to. If it's a growth problem, like the first one, my initial value of 100 should be smaller than the answer. So if it's growing, I should get a bigger number than I started with, 127. Number 6, it was decreasing. So I started with 75, it went down to 43. Okay, so it's going in the correct direction. And if it's not going in that correct direction, something's going on here with your 1 plus or 1 minus r. Okay, so that might be something to go back and check on. Okay, the last thing I just want to go through here is some common growth or decay words. So if something doubles or triples or is half, that is my B value. Okay, growth or decay. So it might be something like doubling is multiplying by 2. So it might be something like a or some number, and then I have 2 to the x power. Okay, so maybe it's something like y equals, maybe it starts at 1. Maybe it just looks like this. So that means that it's doubling. Or maybe it's like y equals 3 times 2 to the x. So that means it's starting with 3 and then just doubling every single period. Okay, triple, so instead of 2, it's going to be 3, because tripling is multiplying by 3. So we're going to have some sort of start value. It could be 1. Okay, so those are some things that then you'll see the pattern of multiplying by 3 over and over. So half would be a half, and we usually will see it as a fraction. So some start value, and then it's 1/2 to the x power. So it's, you know, maybe it starts at 20, then it goes down to 10, then 5, and then continuing on. Okay, so these are kind of some common growth and decay patterns. And so you'll kind of see what I want you to see here is that, you know, doubling, tripling, and then kind of a half-life type of thing. Okay, that wraps up part 2 of growth and decay.